Hi, I'm Patrick from the Python Engineer channel, and in today's video we learn how to build a machine learning web application from scratch. We are going to use real-world data from the Stack Overflow developer survey, and in the first part of this video you will learn how we analyze and clean this data, and then we build a machine learning model and train it with the scikit-learn library. Then later, in the second part of this video, we build a web application in Python using the Streamlit library. This library will make it extremely easy and is really beginner-friendly, so you can follow along without much experience. So now, before we jump to the code, let me show you the final application. So here we are in my browser and I have the final app running, and we're going to build a software developer salary prediction app. So we're going to predict the salary based on a few information that the user has to put in. For example, the first thing we have to put in is the country, and here we get a nice selection box so we can select between different options. Then we have to choose the education level. So here I can say, for example, bachelor's degree. And then we get a nice little slider to select the years of experience. And then we click on calculate salary and get the estimated salary. So in this case, it's 97,000. So let's increase the years of experience and click again. And then we see we get a new higher value. So this is what we should expect if we increase the years of experience. So for this number in the background here, we have our machine learning model running that has been trained on real world data and is now predicting this number based on these three information we give the model. So in the first part of this video, you will learn how to train and then save and reuse this model. And then next to this prediction app, we can also switch to a second site. So here on the left, we have a sidebar and we can choose the explore page. And here we can explore the data that we used. So in this case, we used the real world data, which is the Stack Overflow Developer Survey 2020. So you can find this at this website. We can put the link in the description and you can read through this if you're interested in this. And you can also download this data set. So this is publicly available. So again, we can put the link in the description. And in this video, we used the latest data from 2020, but you can also download the data from the past years. So yeah, on this website, you should download this CSV file and put into your project folder. So let's get back to our web app, and here I simply plot some information to get a nice little overview about this data and also learn how we do plotting in this web app. So the first thing I plot is a little pie chart to plot the number of data from different countries. So we can see the biggest chunk is from the United States, and then we also have a lot of data from the UK, Germany and India and Canada, and then it's getting smaller and smaller. Then if we scroll down, we get the mean salary based on different countries. So this might be a little bit small for you to see, but the biggest average salary is in the United States, which we can see here. And we can also zoom in and zoom out in this plot. So this is really nice. So this is a bar plot. And then down here as last example, I show you how to use a line chart. So here we plot the mean salary based on the number of years of experience. So this is starting at 0 years and goes up to 50 years. And for example, we can see that at the beginning, the salary is increasing almost linearly with the years of experience. But then at some point it's stagnating and it's also jumping around. So from this plot, for example, we learn that we cannot use the years as only information for our model. So we have to combine multiple data points, and we will learn how to do this later. So yeah, this is the final web app that we're going to build, and this is also fully responsive, so we can make this smaller and then it still looks nice. So to build this web app, we are going to use Streamlit. This is a Python library that makes it extremely easy to build beautiful web apps, especially for machine learning and data science tasks. So we will learn how to do this in the second part of this video, and I promise you that this library is really beginner friendly, so it takes care of all the backend stuff for us. And we just have to write a little simple Python script. So yeah, let's do this. And now as first thing, I want you to download this developer survey, so the 2020 CSV file, and put it in your project folder. All right, so here I have this public survey from 2020 open, and this is a really large file, so it's almost 100 megabyte. So you will see that there's a lot of information in here. For example, if we scroll down all the way to the end, then we see we have almost 65,000 data points, so from 65,000 different developers. And then we can also scroll to the right, so you see that there are a lot of different columns in here, so a lot of different questions that they answered. And also for a lot of data points we have NA in here, so not available, so we can't use all the information. So yeah, in the first part now you will learn how we clean this data and then use only the information we want. So let's start with the project setup, and here I'm in a new directory, so I called this ML app, and the first thing I recommend is to create a virtual environment. So you can either use a Python virtual env, and I can display the commands for this here, but in this case I want to use a conda env, so we create a new conda environment. And by the way, if you don't know how to use Anaconda, then you can find a tutorial about this on my page. So we say conda create and then -n, and then we give it a name. So in this case, I want to call this ML for machine learning. And then I also tell it the Python version. So here I want to use the latest one, Python 3.9, and then hit enter and yes. So now it created our environment, and now we want to activate it. So we say conda activate ML, and now this is activated. So in my terminal, we can see this because we see this on the right side. And now we want to install the packages we need. So for this, you could either say pip install and then the libraries I tell you. And this is actually the recommended way for Streamlit. But in my case, I'm on a M1 Mac and I had some issues with pip installs. So I'm just using conda install. This should be just fine. And the first thing we want to say is conda or pip install Streamlit and hit enter. All right, so this installed Streamlit and all the dependencies. For example, it also already installed NumPy and pandas, so we can verify this. If we say conda install NumPy pandas and hit enter, then it should be there already. So we see all requested packages already installed. But we need some more, so we want to say conda install, and then we also want matplotlib for plotting, and we also want scikit-learn for our machine learning model. So again, if you use pip, then this is just fine, but here I use conda, and let's hit enter. All right, so now we have everything we need, and now we want to create a Jupyter notebook, and there we play around with the data and train our model. So we also want to install a kernel for this virtual environment. So for this, we use this command, ipython kernel install --user --name equals, and then the name of this environment. So this is ML in this case. All right, so now we can start our Jupyter notebook server by saying Jupyter notebook and hit enter. All right, so here we see the folder, and you can see that I already have the CSV file with the survey data in this folder, and I also already prepared a notebook. But in your case, you want to click on new and then select the environment. So in this case, ML. And this is why we just used this kernel install command so that we can see this here. So click on new notebook and then you can start. So in my case, I already prepared the notebook and now I will walk you through it. So if this is too fast, and you can find this notebook available on GitHub, we can again put the link in the description. So we want to import pandas and matplotlib, and then we want to read this CSV file by saying pandas.readcsv. So let's execute this cell. And then let's display the first 5 rows by saying dataframe.head. So here we can see the first 5 rows. So as I said, this data set is very large. So we have 61 columns and also a lot of missing data, so NaN. All right, so let's start cleaning the data frame, and we only want to keep a few columns. So we want to keep the column country, the ed level, which is the education level, the years code pro, which is the number of years of professional experience, then the employment status, for example, if the developer is working full-time, and then the converted comp column. So this is the salary converted to US dollars, and this is a yearly salary. So this is what we want to keep, and then we rename this converted comp to salary. So we can do this by saying dataframe.rename. So let's run this and have a look at the head again. And then we can see we only now have the country, the education level, years code pro, employment, and salary. So here, obviously, you can also keep more data. So the more columns or the more information we keep, the better we should be able to train our model later. But here we also want to do a trade-off because we don't want to bother the user with too much information that he or she has to fill out. So yeah, in this case, I'm only using these data points to predict the salary then. So here we can see we already have a lot of missing information where the user didn't put in the salary. So for our training data, now we want only data where the salary is available. So we want to drop all the columns where this is NaN. And we can do this by saying data frame equals data frame where the data frame salary is not null. So if we execute this and have a look, then we see the first rows already have a salary. So now we have a salary for all the data points. So let's have a quick look at the information by saying dataframe.info. So here we see we have almost 35 entries and we have these columns and we also see the data type. So I think object means this is a string. Now the next thing we want to do is we also want to drop all the rows where one of those columns is not a number. So we can do this by saying dataframe equals dataframe.drop NA. And then if we inspect dataframe is null.sum, then we should get a 0 for each column. So now we only use data points where we have data. So of course, just getting rid of all this data is a radical approach of cleaning the data. There are other approaches you can use. For example, you can fill in missing data with the mean of this column. But in this case, we still have enough data points available, so it should be fine to just drop them. Then the next thing we want to do is we only want to keep the data points where the user was employed full-time. So we can do this by saying dataframe equals where data frame employment equals employed full-time. So we only keep these rows and then we want to drop the column employment. So we don't need this for the prediction. So let's run this and again print the info. So now we see we only have these columns and drop the employment. The next thing we want to do is clean the country data. So if we say dataframe country.value counts and hit enter, then we see how many data points we have from each country. So we have the most data from the United States. And we also see that a lot of information, that for a lot of countries, we only have one data point. So now we want to get rid of all the smaller countries. And in no way do I want to offend these countries. So I'm sure there are great developers there. But the thing is just if we use, for example, only one data point from Monaco, then this might actually confuse our model because it can't really learn from this one data point. So for this, now we want to get rid of the countries where we have only a few values. Now, in order to clean the countries, we have this function here, shorten categories, which gets the categories, and this must be these value counts here, and then a cutoff value where we can play around with this. And if the number of samples we have here is greater or equal than the cutoff value, then we keep this. And otherwise, we combine this into a new category that we call other, so the other countries. And then we execute this function. So we say shorten categories, and then we give it dataframe.country.value counts and the cutoff 400 in this case. And then we change our data frame by saying dataframe country equals dataframe country.map and give it this country map. And now if we have a look at the value counts again. All right, so now here we can see we only kept these countries, and United States is still the biggest one. And now here we have the new other category, and here this is the biggest chunk. Now the next thing we want to do is let's inspect the salary range, and for this I want to plot the salary against the country. So let's execute this, and here this is a box plot. So here you see the box plot, and we see the different countries on the x-axis, and then we have the salary ranging from 0 all the way to 2 million. So the way a box plot can be interpreted is that this small area here that you see, this is the median value. And now all these points are actually outliers. So there are a lot of outliers in this data frame. And now actually the most data points are in this median area. So what we want to do here now is we want to keep only the data where we have the most information. So we can see that none of these boxes here reaches over this line, which is $250,000. So we define this as our cutoff value and keep only salaries where this is smaller than this range. So we can do this with this command, and we also only want to keep salaries where this is greater than 10,000. So I think if you're working full-time, then you should earn more than $10,000 in a year. So let's keep only this, and then we also want to drop the other categories. So we can do this with this command. And now let's plot the same again. So the same box plot here, and hit enter. So now we can better detect these boxes here and see where the median range is. And yeah, so now we still have outliers, but not so many anymore. Then the next thing we want to clean is the years code pro. So if we inspect all the different values we get, then we see we have this as a string value. And we also have less than 1 year and more than 50 years. So what I do here is I want to convert this to a float. And if it's less than 1 year, then I just say this is 0.5. And here we do a cutoff. So for more than 50, we just say 50. So for this, we create a function clean experience, which gets x. And here we say if x is more than 50 years, so exactly this string, then we return 50. If it's less than 1 year, we return 0.5, and otherwise we convert it to a float. And then we transform it by saying data frame years code equals data frame years code dot apply this function. So let's hit enter. And now we want to do a similar thing with the education level. So if we have a look at all these unique values, then we see we have all these different answers. And here again, we want to combine a few categories. So I want to keep the bachelor's, the master's degree. Then if it's a professional or a doctoral degree, then I will say this is a postgrad. And for all the other things there, we say this is less than a bachelor's. So for this, again, we create a function, define clean education, where we check if, and then if this string is in X, so if bachelor's degree, then we return this is the bachelor's degree. Then we have the master's degree, the postgrad, and the less than bachelor's. And then again, we apply this to the education level column. So now hit enter, and then let's inspect the unique values again. And now we see we only kept these values. All right, so now we're almost done with cleaning the data, but we still have one problem. And this is because some of our data, for example, the number of years of experience, this is a float. But the education level and the country is a string. And our model can't really understand the string. So what we have to do is we have to transform the string values to a unique value, a number, that our model can understand. For example, for these 4 strings, we can use the numbers 0, 1, 2, and 3. And then in order to transform this data, we can use the label encoder from sclearn.preprocessing. So we import this and then create a label encoder education. And now we fit this to the data and also transform it in the same step. And then we assign it back to the education level column. So now if we have a look at the unique values again, then we see we no longer have strings in here, but now we have the numbers 0, 2, 1, and 3. So the order is not really important here, but this label encoder here now knows which number belongs to which string and then later can convert this back again. So yeah, we did this for the education level, and now we do the same for the country. So we map each country to a unique number, and for this we create a separate label encoder that we call LE country. And then we apply this fit transform again. And now let's have a look at the unique values for the country. And then again, we see we have numbers here and no longer a string. All right, so now we have our final data that we can use. And now we can finally start training our model. So for this, we have to split our data in the features X and the label. So the label is the salary. This is what we predict. And the features are the rest of the columns, so the country, the education level, and the years of experience. So we get these columns by saying data frame drop the salary, and the Y is only the salary column. So now we have X and Y, and now we want to try out different machine learning models, and for this we used the scikit-learn library. And in this case, we deal with a regression problem. And this means that here we don't predict a defined category like cat or dog, but here we predict a number, and the number can be anything from, I don't know, 0 to 1 million. So that's why this is a regression and not a classification. And for this, the first obvious choice is the linear regression model. So we can import this. And then we create a regression model like so. And then like for all the models in the scikit-learn library, first we have to fit the data. So we can fit X and Y dot values and run this. And then to predict new values, we say our model dot predict X. And here we get the predicted values. So let's do this as well. And one note here, so normally you want to split your data into training and testing, or even training, validation, and testing data, and then do the training or the fitting only on the training data. But here for simplicity, we do this on the whole data. So now we get the predictions back, and now in order to evaluate how good our model performs, so for the regression problem, we usually have a look at the mean squared error, or you can also have a look at the mean absolute error. So you can import this. And now we want to calculate the mean squared error based on the actual labels, Y, and the new predicted label. So to get the actual number back, we calculate the square root of this with NumPy square root. And this will be our error. So let's have a look at the error. All right, so this is the error, $39,000. So this means that our model on average is off by this number. And this is still pretty high. If we think that the numbers range from 10,000 all the way to 250,000, and each time we predict the salary, then on average we are off by this value, then it's still pretty high. So let's try out a different model. So the next model we want to try out is the decision tree regressor. So the concept is the very same. We import this, then we create an instance of this, and then we fit the data like so. And then we predict the values. So let's call model.predict. And again, let's calculate the mean squared error and then the root of this and print this. And now this time the root mean squared error is only 29,000. So it's already a lot better. Now let's try out one more. So let's also try out the random forest regressor. So this will basically combine multiple decision trees into a forest. So again, the same approach. We import this, we create one, we fit the data, and then we call model.predict and calculate the error and have a look at this. And this time the error is still 29,000, so it's not really better than the decision tree. So what we do here is obviously a little bit cumbersome. We do this for every model that we find, and then we try out the different values. But now what we didn't consider yet is that for each of these models, we also can use different parameter values that we can put in. For example, for a decision tree, we can use the max depth parameter, and then it might perform very differently for different parameters. So in order to find the best model with the best parameters, there is a so-called grid search CV method, which stands for grid search with cross-validation. And the way this works is we import this, and then we define the set of different parameters we want to try out. For example, for the max depth parameter, we can try out these different values. Then we create a dictionary with this, and this has to be the same name as the keyword argument for the, in this case, the decision tree regressor. So you can find this in the scikit-learn documentation. And then we create a grid search CV with this regressor and the parameters. And in this case, the scoring is the negated mean squared error. So this is just what we want to use for a regression problem with the grid search. And then again, we call the fit method with x and y and run this. And now what is happening here, so this will basically loop over all the different parameters that we put in here and try out all the different parameters and each time evaluate the error and then chooses the best model for us. So now this has been executed, and now we get the best estimator by saying grid search.best estimator underscore. So now let's use this best estimator here as our regressor. And now again, let's train it on the whole training data and then calculate the error and see what we get. So this is the final error we get for our final regressor, and this is actually higher again than this one we used here. And this might be a little bit surprising because actually we search for the best one here. But what could have happened here is that in the decision trees there is some kind of randomness in it, even though we set random state equals 0. So it might be slightly worse again, but that's fine. So we still keep this regressor now and continue with this. So now let's learn how to apply this to new data like we have to do in the app later. So let's have a quick look at the data frame again. And we see we have these columns: country, education level, and years code pro. So let's say in the app later we get a new array and it will have these values. So here we start with the strings that the user puts in. So the country, the degree, and the experience. So now our X looks like this. And now what we do here is we want to apply the label encoder for the country. So the country is the first or the 0 column. Then we want to apply the label encoder for the education. And then we also want to have this as a float array. So let's apply this. And then we see now we get these values and we can put this in our regressor and then predict this. So yeah, with these information, we get this predicted salary. And now this is what we have to do in our app. But before we can use this in our app first, we have to, of course, save our model. And for this, we use pickle. So we can say import pickle. And then we want to save the regressor, the label encoder for the country, and the label encoder for the education. So for this, we create a dictionary. Then we open a pickle file. And here we want to open this in write binary mode. So this is important for pickle here. And then we say pickle dump the data, so this here in this file. So now if we execute this, then this should save this data in our directory. And we can check this by loading it again in read binary mode and then say data equals pickle.load. And then we can access the model, the label encoder for the country and for the education by accessing the key. So let's get them back from the data and run this. And then let's run the prediction with our loaded model again. And then we see we get the exact same number that we get here from the original model. So saving and loading works. All right, so now we are done with our Jupyter notebook. So now we have the complete pipeline here. So we learned how we can clean the data and then create our model and train it and save it. And now we have to convert some of the code from here to our app. So let's do this. So now let's create our Streamlit app. And for this, let's open your editor of choice. And you can see that inside this directory, now we have the CSV file and we also have the saved pickle file and we have the notebook. So yeah, this saving step here worked. So now let's create 3 new files. So let's create one app.py file. Then let's create a separate file for the predict page. So we call this predict_page.py, and let's create another one and we want to call this explore_page.py. So let's start with the predict page, and first of course we want to import these things we need. So we import Streamlit as st. Then we also need pickle to load the data. So import pickle, and we need NumPy. So we import NumPy as np. And now we need some code from our notebook. So the first thing is we want to load the model. So let's create a function define load model. And here, let's go back to our notebook. Here we want to copy this part of the code. So we open our pickled file and say this is our data, and then here we return the data. Then of course we want to execute this, so we say data equals load model, and now we want to access the different keys like we did here. So we create the regressor, the label encoder for the country and for the education. So let's simply call this regressor. So now let's create the prediction page, and I again wrap this into a function, and later you will see why I do this. So let's create a function and let's call this show predict_page. And here now we will build our Streamlit application, and the way this works is we create different widgets. For example, we can say streamlit.title. And then here we can say software developer salary prediction. So now this will display a title. And for example, we can also simply write text by saying streamlit.write. And then here we can use a multi-line string, and we can use a markdown syntax here. For example, if we use 3 hashtags, then this will be a h3 tag. So let's say we need some information to predict the salary. So now let's save this, and now in the terminal, so here again I want to say conda activate ml. And now in order to run this file, we say streamlit and then run. And now for the first example, let's use this predict_page.py. So now if we execute this, then this will start the server. So now it will open up the app. And as you can see, we don't see anything. And this is because we only defined the page, but we didn't execute this. So now in order to execute this, actually I want to run this from the main app.py file. So here again we say import Streamlit, And then we import this show predict page. So we say from predict page, we import this function show predict page. And then let's execute this here. And now let's quit the server again by hitting Control-C. And then let's say Streamlit run. And then we actually want to run the app.py file. And now if we go to this address again, then now we see we have our app up and running. So now this is working. So now the next thing here is what we want to add is we want to add 2 select boxes for the countries and the educations. So let me copy and paste this in here. And this here is a tuple with all the different choices. So all these countries, and you can find them in your notebook, for example, at this position where we printed the value counts. So all these different countries that we keep, so we don't keep the other category. So these are all the different choices for the countries. And then the same with the education level. So these are the exact names of the education categories that we keep. And now in order to create a select box, we can say country equals streamlit dot select box, and now this must get the number of choices. So here the countries, which can be a tuple or a list. So here we use a tuple, and we can give this a name as first argument. So we can say country and then comma countries. And now if we save this and go back to our app, we can click on rerun. And now here we see we have our select box. So this is working. So yeah, pretty cool. And now what happens here is if we choose a different value here, for example, Germany, then in our script, this will be the value of this variable. So now this will, our country will be Germany, and then we can work with this. So yeah, let's copy and paste this in here. And now we also want a select box for the education. So let's call this education. And then as a string, we use education level. And here we put in all the different education choices that we defined. So education level. So now we have this, and now we want to select the years of experience. So experience equals, and for this we use a slider. And we get this by saying streamlit.slider, and then the name we say years of experience. And then we can give this a min value, a max value, and a default value. So let's say this should range from 0 to 50, and the start value is 3. So now again, let's save this and let's go to our app and run this. And then we see we have the education level as selection box, and we have the slider with the default 3. So now this is working as well. So let's add a button to start the prediction. So we can add a button by saying streamlit.button, and then the name for this button is, let's say, let's call this calculate salary. And now again, we can assign this to a variable. So we can say OK equals streamlit.button. So this means that if we don't click on the button, then this is false. And if we click on the button, then this is true. So now only if this is true, if we clicked on the button, then what we want to do here is we want to start the prediction. So let's go back to our notebook. And now what we want to do here is the same as I did here. So we created this NumPy array like we do here. So let's copy and paste this. Then we transform the country, the education, want it as a float, like so. And then we predict it. So let's copy and paste this as well. So now here we have the transforms for our NumPy array. And now here, instead of these hard-coded values, the nice thing is that we already have the information. So the this is just the country variable that we get from this select box. This is the education level, and this is the experience level. So now we have all the information that we need. And now we simply need to calculate the prediction. So we say salary equals, and then we say regressor dot predict, and we want to predict our x. And now as last thing, we want to display this. So for this, for example, we can say Streamlit dot write, or here I show you another thing. So we can use the sub header, which is kind of a smaller header. And here let's use a f string, and then let's say the estimated salary is, and then this is in dollar. And now let's use our variable here. So this is the salary, and this is a NumPy array with only one value in it. So we want to access the first value like so. And we also want to display it with only 2 decimal values, so we can format it like this. So let's save this and let's go back to our app again and rerun this. And then we have the button. And now if we click this, then we should see the results. So let's try it out. And yeah, this is working. So here we see we chose Germany, and we have less than a bachelor's and 3 years experience, and this is our predicted salary. Now, for example, let's try this out. So for example, if we use the United States, then this is higher than in Germany. So now we have the prediction page. So let's add a sidebar, and then let's also add the second page. So for the sidebar, what we do here is we go to the app.py file, and again we create a selection box by saying streamlit.selectBox, and then here as first argument we give it the title. So let's call this explore or predict. And then as second argument, as a tuple, we give it the 2 choices. So we want the predict page and we want the explore page. So now let's first save this and have a look at the app again. And here we see a error, name st is not defined. And this is, by the way, very nice in Streamlit. So we immediately see the error here in a nice way. So if we go back, obviously I have to import Streamlit as st. So let's save this again and check our app again. And now we have this select box here, explore or predict. And now in order to create a sidebar, the only thing we have to do is call st.sidebar and then .selectBox. So with this, we can move any widget, for example, also a button or a slider to the sidebar. So now if we go back, then we should see the sidebar. So yeah, this is working. Now we have a nice little sidebar where we can choose between the different sites. So now the only thing left to do is implement the explore page. So let's implement the explore page.py. So here again, we import Streamlit as st, then we import pandas as pd, then we import matplotlib.pyplot as plt. And now we want to load and clean the data the same way we did it in the notebook. So let's go back to our notebook and let's copy all the things we need to clean the data. So for this, we want to, for example, copy these functions that we applied. So we simply copy and paste this in here. Then let's have a look. We also, at some point, we cleaned the experience like so. So let's also copy and paste this in here. Then let me close this here. And now let's also search for the clean education. So we copy and paste this from our notebook. So now we need a function to load the data. So let's call this define load data. And now here we load the data frame and then we apply all the transformations that we did in this notebook. So here, first, of course, we load the CSV file. And now let's go back through our notebook and apply all the transformations that we did here. So take only the columns we want. Then we rename the converted comp to salary. So now we have to go through this notebook and copy and paste all the transformations that we apply. So I will simplify this for you and just copy and paste all the steps that we used in here. So yeah, these are the exact same steps that we used in the notebook, and we apply them here, and then we return the data frame from this function. So now we have our load data function, and of course we also want to execute this. So we say data frame equals load data. And now I want to show you a nice little tip that we can do with Streamlit. So now whenever we refresh the page, then it will load the data again because it will execute this script from the top. So in order to avoid loading this again and again and applying all these steps again, we can actually cache this step simply by using a decorator, and this is st.cache. So now this, once we have executed this one time, then it will cache it and it is available the next time again. So this is a nice little trick that we can do with Streamlit to improve the performance of our app. So now we come to the actual page that we want to display. And again, for this, we create a function and we call this show explore page. And here again, we give it a title and then a smaller title by saying streamlit.title and then streamlit.write. And now for this little example, I want to display 3 different charts, one pie chart, one bar plot, and one line chart. So for the pie chart, we want to plot the value counts of the country. So we can access the country like so, and then we can get the value counts by calling value counts. And now we want to put this into a pie chart, and for this we use matplotlib, and then let's simply copy and paste this for you. So we create a subplot, and then we can call axis.pie with this data, and the labels is data.index. And then here are some more arguments to get a nicer look. And now in order to actually display this, so first let's write a little heading first by saying streamlit.write. And then here as a multi-line string in markdown format like so, let's use a h4 tag. And then we say number of data from different countries. And now we want to actually plot this figure here, and we can do this in Streamlit by saying streamlit.pyplot and then the figure 1. And here we can display any matplotlib figure that we created. So this is pretty nice. So now let's save this, and now let's actually show this. And for this we have to do one change here in the app.py. So we also want to import this function. So we say from explore page, we import the show explore page. And now from our select box, we want to save the selection in a variable. So we call this page, and then we say if page equals, if this is the predict value, then we show the show predict page, and otherwise we say, sorry, this must be here. Otherwise we say show explore page, and now this should work. So now if we go back to our app and rerun this, and then we get a key error, converted comp. So let's have a look at where we load the data, and here I renamed this to salary, but then I access it here and here and here again. So let's actually do the rename step at the very end, so it doesn't really matter. So like here, and now let's go back, and now this should work. So let's rerun this, and now let's select the explore page. And I think we have one more typo. So again, let's go back, and here we want the country, of course. So country, and save it again and rerun it. And now it's working. So yeah, here we have our pie chart. So let me make this side smaller again. So let's add two more charts, the bar chart and the line chart. So first, let's again write a little heading. So we say Streamlit.write the mean salary based on the country. And now the data we want to plot is, we get it like so. So we want to group the data frame by the country and then access the salary for each country and calculate the mean value and also sort it in ascending order. So we get this like so. And then in order to plot this, we can use the built-in bar chart of Streamlit by saying Streamlit.barChart with the data like so. And now this is all we need. So now if we go back and again rerun this, then here we see the bar chart. So this is working pretty nicely. And now we see we have all the different average or mean salaries for each country. And now as last thing, let's also use a line chart. So for this, let's again write some text, Streamlit.write the mean salary based on the experience. And here we do the same thing. We call this group by, but here we want to group by, and this is called years code pro. And then again, the salary, and we calculate the mean and sort it. And now we create a line chart by calling Streamlit.lineChart with this data and save this and run it again and reload this. And now, yeah, this is working as well. Here we have our line chart. All right, so yeah, this is our final app, and this is all that I wanted to put in this example. Obviously, you can play around with this and show different data as well. So yeah, I recommend that you do this. And also I recommend that you play around with this model here and maybe try to improve this on your own. For example, you might try to use more than just the 3 information that we put in. For example, you can also try to use the age and use this as well for training. But yeah, that's it for now. And hopefully you enjoyed this little tutorial and now know how you can build a machine learning web app from scratch with real data. And then I hope to see you in one of my next videos. Bye.